Hello everyone, welcome back to my channel, and today is the 29 of 100 days of DevOps. We'll continue with studying of containerization. If you're coming across this channel for the first time, what we're trying to do is that we're trying to cover DevOps, the fundamentals of DevOps in 100 days so that you can be very well equipped, and have good knowledge in terms of DevOps and in terms of building yourself and building your DevOps career. And we started from the very, very basic, which is understanding Linux. We've taken it one step at a time, from Linux to shell scripting to networking to version control. We covered web servers, and we're currently in the phase 2, which is containerization and CI/CD. So for the past 7 days, we covered Docker fundamentals, and we wrapped it up with a very simple mini project yesterday, which is connecting multi-containers together and seeing the connection between them, and persistent storage, basically wrapping or tying up everything we've been covering since into a small project, because the base or the reason for this journey is not just to understand things theoretically, is to be able to apply them practically so that we see how things work real life. And if you've not seen that video, it's something that you really want to see. It's a very, very interesting mini project which you can just not just deploy but also build on, because over the next couple of days we'll be building on that particular project, and we don't know. Let's see how far it's going to take us. So towards the end of the project yesterday, I mentioned that there was a better way to do it, to do the project. So basically what we did was, like I said yesterday, we connected two containers, Nginx, with a front end and back end. Front end was served with Nginx and back end was built with Python. And then we created a persistent volume for the back end, and then we connected both the front end and the back end to a user-defined network which we created, so that we can allow communication between the front end and the back end, and we tested it and it was working fine. However, we ran these commands separately. Like, we had to spin up the front end separately, and then we spin up the back end separately. And I said for 1 or 2 containers you can actually do that, but when you have like 10 microservices that you have to run together, or 20 microservices that you have to run together, you can't keep using the CLI to manually spin up containers. And one of the things that DevOps have come to take away is doing things manually, like doing repeated things manually. DevOps is really about automation. Those repeated tasks, how can you do it, or how can you structure it in a way that you don't have to run the command? So just imagine that I have like 20 services that I want to spin up, and I'm using the CLI. That means I have to run that CLI command 20 times, and that increases the risk of me making mistakes. I might forget to map one container to the port, to a volume, or map one container to maybe a network, or forget to assign the port number to one. So they are actually it increases the chances of making mistakes. So, and that's why we're going to be covering some advanced concepts of Docker in the next couple of days, and we'll see how it takes us. So now, in a case where you have so many microservices, what then do you do? That is where a tool called docker-compose comes in. So basically, docker-compose is a tool for defining and running multi-container applications. So basically, when you have like so many containers that you need to run at a time, the best approach is to use docker-compose, and that is what we are going to start with. This is the second phase of the containerization. So this is the second phase. We covered the fundamentals in the last 7 days. We're going to be looking at a little more advanced concept in the next 6 to 7 days. Don't get it confused or scared. Docker, everything about containerization is actually not rocket science. It's simple. So yes, you might me saying it's advanced doesn't mean that it's going to be maybe more difficult or more technical and all of that. No. So let's quickly dive into what we have for today. Hopefully it's not a long session. So like I said, Docker Compose is a tool for defining and running multi-container applications. So basically you use a YAML file. You define your configuration in a YAML file. If you don't know what a YAML file is, or you don't really understand what YAML files are, I have a video on that. I think, let me see, what day is that? So I think that should be what day is that? It should be in one of these days. I'm trying to see the day. I know we covered YAML. We had a separate, okay, yeah. So I have two videos for YAML. We have YAML basics and YAML advanced techniques. So you can see those two videos. I'm sure you're going to, afterwards, you'll be able to understand what YAML files are and basically how to work with YAML files. So you define your configuration in a YAML file and you spin them up. So instead of typing all those commands one after the other using the Docker CLI, you just have a file and then you just use the Docker Compose to spin up everything in that file. So basically that is how it works. So if I go here and now see why use Compose. Basically it simplifies control, because you are able to manage it better. Now you can actually go to the file, you can edit what you want to edit. It makes your work much better, in the sense that if you have any changes, you can just go to the compose file and then you just make the necessary edits that you want to make. Collaboration, rapid application deployments, because you can deploy everything at once. It has its benefit. And how does it work exactly? So basically, you use a YAML file, like I said. It's called a compose file. So you can name it compose.yml, or you can use docker-compose.yml, depending on how you want to use it. So basically, that's just how it works. I'm trying to see if I can see an example. Okay. So this is an example of it's similar to what we are going to do today, so it's good. I'm even saying this now. So you have two services here. You have the front end, you have the back end. So you just define the image, define the port, you define the network. If there's any configuration, you define it. If there's any secret, you add it also. So same thing with the back end. Basically you are just defining things. You are using list dictionary objects, basically. List dictionary, object key value pairs, just like the whole concept of YAML is. So now that we have a good overview of what Docker Compose is, we are going to take the same project we worked on yesterday and then we'll see how we can apply it into Docker Compose. Instead of running the commands one after the other, how can we have a single file where we can put all of this and then we can use a single file to run the commands. So let's go straight to our terminal. If I do ls, I have the front end and the back end here. We built our image yesterday. So when I do Docker images, I have the front end image, the back end image, and I didn't delete the volume. So we still have our volume. I also did not delete the network. So we still have everything intact because I knew we were going to be using it for today. So if I do Docker PS, they are not running services, PS-A. So I don't have any running services. Now, the first thing we have to do is to create a file. The approved naming convention of your file should be either compose.yml in this format or compose.yml, or you use docker-compose.yml or either of these. So there are 4 ways you can actually name your compose file, but this is the most preferred way that Docker recognizes. But regardless, I'm going to go with this because I'm kind of used to this. So let me create a file called compose.yml. So when I do ls, so I have your compose.yml. So first things first, let me go to my slide. So I'm just going to run us through the components of what is in it, what you expect in a Docker Compose file on a high level. So these are different things that can be put in your compose file. So now you see, if you see services means that a list of services. For example, now you have your front end, you have your back end. The front end is a service, the back end is a service. If you have your authentication container tool, your auth is also a service. So basically, it's like services is similar to the name you are giving your container. The name you're giving your container. So that's what services is. So build, for example, when I did Docker images, I saw that I already built the image yesterday. So if it was a case where you had not built the image yesterday, you can actually use Docker build. You can actually use Docker Compose to build your image. So you define the build. All these are actually there are some that are lists, there are some that are key value pairs, there are some that are list of dictionaries. So depending, you just have to be familiar with it, do further studies on your own. With more practice, you understand how to place each of these components and where to place it. I can assure you it's not something that is really difficult. So now, from build, the other option is image. So we are going to be using image today because we already built our application, our images yesterday. So if it was a case where if you're not building or you already have the image, you just use image. Port basically just defines the port, you map the port. Volumes is just the volume mount. Network is just network mount. Restart, you can use restart policy. Restart policy basically means that if the container goes down, it restarts automatically. It's just like a little bit similar to self-healing. So basically the container will just restart automatically after going down. And then the last I have on my list here is depends on. Basically, there are some services that you need other service to run before that particular service runs. So in that case, you don't want you don't want all the services to run at the same time. Basically, if you're spinning up a Docker Compose file, all the services will come up at the same time. That's the way it's designed. But now, if you don't want all the services to come up at the same time, there are some services that used to wait for other services to start first before they can start for effective communication. So in that case, you just use depends on. So when you define depends on, when you do depends on, you will name the service that needs to start first before the service starts. So until that service that this one is dependent on, until it starts, the other one will not start. So basically, it's just simple and straightforward. So without wasting much time, I will just go to our terminal and then we'll see how we can do the same thing we did yesterday, but this time around using a compose file. And it's actually going to be very, very simple. We shouldn't waste time at all. So let's vim into Docker Compose. So the first thing you do is, first of all, you want to define your services. You want to define your services, and when you're defining your service, that means all the services will be under services. All the services will be under services. So basically, we have two services here. We have the front end and we have the back end. So we have the front end and we have the back end. So now from the front end, we will define the things that we want to include in our front end. So the first thing is we want to do image. Is it image or images? Let me confirm. Image. So we'll define the image. We'll define the port. Let me do ports. We'll also define the networks. Now, those are the three things that we are defining for the front end. Why for the back end? This is exactly what we did yesterday. We gave it an image name, and we mapped it to a port and mapped it to a network. So basically, we are doing the same thing. So it's not like it's one big deal or rocket science. So in the same way, we'll define the image, we'll define the ports. Now for backend, we added volumes. So we're going to also define volume. That's the only difference between the back end and the front end. We'll do networks. So those are the 4 things that we'll define for the back end. So towards the end, you define your volumes and your network. So the volume that we have here is logger underscore logs. That's the volume that we created yesterday. And the networks find is, I think, logger -net. I think is -net. Yeah, so the reason why I'm defining this volume and network is that by default, if you're using Docker Compose, you actually don't need to define your network. By default, Docker Compose will automatically create a bridge network for you when you run Docker Compose up. So it basically defines, like, you automatically create. That's the way it was created. So you don't really have to stress yourself about, first of all, defining your network and all of that. With Docker Compose, it comes with the whole package. So it defines your network. But if you have a network that you want to map to it, then you need to explicitly state it in your compose file, so that instead of Docker Compose instead of Docker Compose creating a network for you, it will just use the network that you have defined. So that's just the reason why you have to define, after the whole configuration, towards the end, you need to define your volumes and the network. If not, if you don't do it, Docker Compose will go ahead and create these things automatically for you. Yes, it's good if you are just testing. For testing sake, for project and practical sake, understanding the architecture more better, it's okay if you don't define your network, if you just let Docker Compose do all those things for you so that you understand better. But in a production environment, we usually define those things down because we want to have control over how all of these microservices talk with each other, how they talk together. So you need to actually define the network, and then you need to put it in the compose file so that Docker Compose can see it and use it instead. So there will be some times that we'll have multiple networks, multiple volumes. So you just list everything, and then Docker Compose knows how to, arrange each one of them to each other. Basically, that's just why you need to explicitly state this. So for the image, for the front-end image, I really can't remember the name. So let me do Docker images. Okay, Docker logger-front-end image, logger-backend image. Okay. So let's vim this, and we'll do logger front-end image. And the port that we defined yesterday, even from our introductory class, port is always a list. So we are defining, let's map it to let's see, 8086, mapping 8086 to port 80 on our container. And then network, because we can have more than one network is also a list. So can do logger net. So that's basically all we defined for front end. And this is exactly what we did yesterday. we gave it a name, we mapped it to a port, and we mapped it to a network. This is basically what we did yesterday. So for backend, we'll do the same thing. Backend image, the port, since it's a Python container, so port 5000 to 5000. Volume, so we created a volume, logger logs, and then we mapped it to this. This is exactly what we did yesterday. So if you followed the video of yesterday, you will see that we are doing the same thing. But this time around, instead of typing those using the CLI and running the commands one after the other, we are just defining it in a file. So it's the same thing. It's not rocket science. We are basically doing the same thing, but this time around it's in a more arranged manner. So, and that's pretty much all. We've defined our image, we've defined the port, we've defined the volume for the back end, and also defined the network. So there's no other thing else to do. So let's save it. So just like that, we've written our compose file. So how then do you spin up a Docker compose file? There's a command for it. It's called docker-compose up. So what it does is, well, if I run docker compose up, it reads this docker compose file and then does all the things that are inside the compose file. It spins everything up and then you can access it. So let me I just wanted to check something. Just wanted to be sure I gave you the correct network name. Okay, so docker compose up. You can use the -d also. Okay, let me use the -d to run it in a detached mode. Or let me run it like this. So when I do this, let's see. Fingers crossed. Docker compose not found. Okay. Let me move the. Let's see. Validating. Additional properties, network not allowed. Okay. Let's see what the issue is. Okay. I see where the issue is. It said network not allowed. It should be networks, not network. Because like I said, you can have more than one network. So the proper name is networks, not network. So let me clear it. Let's see if it's going to work this time around. Hopefully it works. Okay, great. So you can see network is created, the volume is created, the container is created, the front-end container is created, the back-end container is created. So basically, we have our front end, we have our back end. So if I should go to my terminal and I run my IP address 192.168.199.136, I did 8086, yes. When I run this, I have my front end up and running. So let me send the message. Let me confirm if my back end is also running. 192.168.199.136.5000. Good. Logger backend is also running. So let me send a message. We are testing the use of Docker compose. So let me submit. Good. So if we go back to our terminal, you would see the front end. We access the front end. You can see it here. A GET request. There's also a GET request. And then you can see the back end received it now, and you can see that a post request was made to the back end and the code was 200, which means that it was successfully sent to the back end. So if I open a new tab, let me duplicate this tab. Let me increase the font size. Okay, it's not. Just give me a sec. Okay, font size is not increasing. Okay, so all right, awesome. So when I do docker ps, I can see that both my front end and my back end, they are actually, working fine. I can also do docker compose ps. No configuration. Fine, okay. Docker compose ps. Okay. So docker compose ps also shows me that I can either do docker ps or docker compose ps. So both will give me the same thing. The thing is that if you're using docker ps, you can run docker ps like in any place. But if you want to run docker compose ps, you have to be in the directory where the docker compose file is. So that's basically the difference. So when I do docker exec, I want to go into the back end to see if we have the message we sent yesterday and the one that we sent today. -it. I need the ID of the back end. Bash. Okay. cd. I do ls. I can see that I have my logs here. So when I cd to logs and I do ls, I have my logs.txt. So when I cut logs.txt, I'm supposed to see, oh, we are testing the use of docker compose. That's strange. I'm supposed to see yesterday's log. Let me see. Oh, I see. Okay. So the network and the volume that Docker Compose created was actually different. Let's confirm that. Let's exit. Let's do Docker network ls. Oh, so Docker Compose created a new network, and Docker volume ls, it created a new volume. All right, that's fine. So that's the way Docker Compose basically works. You can use it to spin up different containers that are working, that are to interact or that are to communicate with each other. So let me how do we stop this now? When we want to bring down, or when we want to stop a container, we usually use the command docker stop, and that we have to run it with the container IDs and all of that. But with Docker Compose, I can use Ctrl+C to exit from this terminal. That's if I just want to use a quick way. But the actual command is docker compose down. So we use docker compose up to spin up the container. We use docker compose down to actually bring down the containers. So when I run it, it will bring down everything. So it's bringing down the containers, stopping, and it's removing. It takes away, it removes everything. That's what Docker Compose does. It removes everything. So let's give it a sec. Okay, the network was removed and all of that. So when I do docker network ls, you can see that network is not there again. If I do docker volume ls, the volume is still there. So I should have actually allowed docker volume to create docker compose to create a volume instead of trying to map it to my volume. But I think there should be a way for this to actually work. So for me to be able to map my original volume to this new volume that is created. I'm sure there will be a way. So that's basically what I have for today. I hope that basically it's just to introduce us to the concept of Docker Compose. Basically, Docker Compose is just a step ahead. It's built on top of the Docker CLI. It's like an advancement of the Docker CLI in the sense that instead of running the commands one after the other, if you have a case of you have like 20 microservices, you wouldn't have to run the commands one after the other. You can just use the Docker Compose file, put everything, what you actually run on normal CLI, you can put everything in a YAML file, and then you just use Docker Compose up to spin up the YAML file, and you have all your services running. So we'll continue in that progression tomorrow. That's basically what I have today. For this volume, I'm going to do more findings on why it didn't map the volume to the previous one, despite me defining it in the compose file. And that's the first thing I'm going to cover when we meet again tomorrow. So if you've actually enjoyed this video, please do well to like the video, share it to your friends that will be interested, and also subscribe, and most importantly, turn on your notification bell so that when I post new videos, you would get them immediately and be able to add to your knowledge. And I really hope that you've learned a thing or two about Docker Compose. It's not really rocket science. It's straightforward. It's just arranging all your multi-services in your file and then using a command to spin them up. It makes things easier for you and easier for you to do your work as both a DevOps engineer, a cloud engineer, even a software developer. So that said, I'll see you again tomorrow. Enjoy the rest of your day. Cheers.